It's just a really efficient way. So if I'm allocating a megabyte buffer in memory, I don't have to have a megabyte of nulls in my file, for example. And it's important to note that iPhone binaries, the text section is encrypted. So what do? The second pass that the Mako linker takes is to look at the LC encryption info load command, and will actually decrypt a certain portion of the text segment and map it into memory unprotected. Both OS X and the iPhone do this. If you want the juicy details, all of this is open source. So I haven't seen too much research into how this typically works, but I'd like to see more. I think it's really interesting stuff. So given that the text section is encrypted, what can we actually see? In our analysis, we're not currently decrypting the text section. We do have the link edit table. So we get to see all the symbols in the binary. And basically every application I've seen in the iPhone App Store is very gratuitous in the symbols that it actually gives us. Also, we get to see load commands that show what frameworks we're linking with at runtime. So what are we doing to analyze iPhone apps? Specifically, we're looking at the symbol table, which tells us defined, which are implemented symbols. So if a symbol is defined, it's a class that your application has. If a symbol is undefined, it's a class that your application references. So it may be a framework API. This is true for C functions as well as Objective-C, classes, methods, and instance variables. And it's also interesting to note that Objective-C is a strict superset of C, so everything compiles down to C, and it plays really nicely. We're not doing a VM here, for example. And similar to Android, we want to define heuristics to identify features, capabilities, vulnerabilities, for example. And one example of an iPhone heuristic is we can look at whether an application imports any address book APIs that allow you to read contact data, for example. Or we can really just run arbitrary queries against the application data set as a whole. And we're actually able to hit every application on a whole data set in about 5 hours right now on Android and iPhone and run arbitrary queries against it. So that's pretty cool. I mean, you imagine in the PC space, if you were to ask, how do I ask a question about every PC application written? And that's an almost intractable problem. But the fact that we can actually do that in a reasonable amount of time on mobile may not stay that way forever, but it really helps us right now. So the constraints on what we're analyzing here, I mean, as I've said, we're not analyzing the text section. So that limits the amount of automated static analysis we can do without decrypting things. If people find ways to decrypt, more stuff will happen. And we're not looking for dynamically loaded code because the constants are typically stored in text. And also bypassing frameworks via private APIs. A lot of this stuff won't be able to get into the App Store anyway. So we're not able to analyze that right now. And code downloaded at runtime, of course. And if you exploit libtiff, for example, in your iPhone app and you're downloading code at runtime, we're obviously not going to be able to catch that. So kind of to tie it all up in a bow, we download a whole bunch of applications on Android and iPhone, and we built some tools to analyze this data en masse. So we don't have to drink Red Bull and do it manually. And so now, what sort of questions are we going to ask this data? And what did we find? So I'm going to tell a series of stories. The first story is basically how, when we first got this data set, what did we do? We ask a simple question. Are there any apps stealing my contact list? I'm rather worried about myself and my friends getting spammed. And we came up with, wow, 14% of apps on iPhone and 8% of apps on Android are accessing contacts. That's quite a bit. Let's pick one. Let's see why one of these apps is doing this. We first looked at an Android app, a soundboard app. And we said, well, why is a soundboard accessing my contact lists? That's pretty weird, right? So it requests the right contacts permission on Android, and it references the contacts API. Specifically, in this case, it pulled out the URI for the content provider. We would also found it if it had a string for a content provider, if it referenced any content provider or a content provider methods. So why is this Star Wars soundboard accessing my contacts, you might add? Well, it turns out I didn't have to spend too long, and I found that you can actually set a custom ringtone from one of the Star Wars sounds. I've I've got a bad feeling about this whenever John calls me. And in the analysis, this is an excerpt at the bottom here of a tool called Boxmali, which is Icelandic for disassembler. I don't know what it is with Android and Icelandic, but it's a great tool. And so we found that the class definitions themselves showed us that the purpose was to assign ringtones to contacts. Looking at what is actually inside this method, that's the only time we access contacts, and it's perfectly legitimate. And so what's the point? Not all apps that access sensitive data are bad.
Yeah, just to reiterate that, not all apps that access sensitive data are bad.
Not all apps that access sensitive data are bad.
So we'll talk more about vulnerabilities and additional apps that are potentially bad. But I think what's important is understanding what apps can and can't do fundamentally. It's actually a good thing that apps have permissions and can access lots of data. That's what allows us to have really cool apps. So that's important, and we should not be afraid of that. We need to embrace that, as a matter of fact. But what's more important to understand is that we need to, as security professionals, understand what is possible, and then look in and actually specifically look at the details and understand what is bad in the very, very small amount of cases, and then be able to go on broad scale and look at if that's actually happening in the wild to respond to that.
Absolutely. Story number 2. So in that crushing defeat of not having found bad things in the wild, we said, okay, well, what else might something steal from me? Are there any applications looking at my location? And similarly, we found that, wow, there's a lot of applications looking at my location. 33% on iPhone, 29% of all applications on Android accessing location.
Which is crazy when you think about it. A third of all free apps know where you are.
So we started going through these apps. There's a lot of them. And apps that access location but didn't seem to need it. These are things that seemingly anomalous, like the soundboard. We said, why does the soundboard need to access this? And what we actually found is over and over and over and over again, we found that third-party SDKs were the only piece of code in the application that was accessing the location. And we found that actually interesting. It turned out to be third-party advertising SDKs. When you think about it, it makes a lot of sense. An advertising SDK can access your location in order to serve you more targeted ads. It's the Gmail value proposition, right? Gmail looks at your email in order to serve you more targeted ads, and so you don't have to see a giant banner. And people are aware of this. I use Gmail personally. As long as everyone knows what's happening, it's a good thing.
Yeah, it is a good thing.
So when we look closer, one application in particular, we looked at that had the Quattro Wireless SDK. In the Android simulator, we were actually able to pretend we were at 3.1337, and we Wiresharked it, as all good reverse engineering things start with. And we found a plain text HTTP request to ad.quappy.com, which is Quattro Wireless's ad servers. And I broke down the request just so it's easier to read. And sure enough, we have a poorly rounded version of our latitude and longitude being sent in plain text to an ad server. This is really interesting. So let's zoom out a little bit and say, okay, given that an application implements a certain third-party SDK, what is its likelihood to access location? And these are the numbers we came up with some pretty popular third-party SDKs. iPhone and Android. I think it's really important to take these numbers into context, and I think the insights on the next page will put that into context. So specifically, the numbers on Android were generally lower. That is partially an artifact due to how we analyze things. For example, if a developer on Android brings in an ad SDK, and that ad SDK wants to access location, but the developer doesn't request the location permission, the ad SDK doesn't get location.
Which is a really cool aspect of Android, by the way. It's pretty focused on keeping the consumer's data private.
And so our analysis takes that into account. So if an application tries to access location but it doesn't have permission to do so, that application doesn't access location because it can't. On iPhone, for example, an application is only allowed to use location if Apple deems it appropriate. And they actually had a kind of a fairly big issue earlier this year, and they came out with a statement basically saying that they will only approve applications that use location if the application already uses location. So if you download a mapping application or a restaurant locator application, it's okay to have location-based ads there. It's not okay to have location-based ads in iFart, for example, unless that uses location. And so when we wanted to look at the prevalence of third-party code as a whole, we actually found it was quite prevalent on both iPhone and Android. 23% of applications had one of 8 popular SDKs in them, 47% on Android. And and I think this is a good thing in the sense that we're actually seeing developers share code, and we're actually seeing these SDKs get adoption. I think it's very important, and we ask, well, what's the point? Our goal here is that to help people understand what is going on inside of applications, and especially that there's a lot of novice developers who just, hey, I want to develop a mobile application. And I think it's great that the SDKs make it so easy to get a mobile application out in the wild, but we want to make sure that people understand the ramifications of what they're doing. So when a developer brings in third-party code, they don't always know what's in it. And in fact, because it's closed source, even very experienced developers don't know what's in it. But depending on the platform, you oftentimes have a lot of control. For example, on Android, a developer gets to choose permissions. Even though they don't get to write the code, they get to choose what permissions their application requests. So an SDK may just say, hey, copy and paste these permissions into your Android manifest. But you don't have to do that. You get to put what you want. And I think that's the power that with educated developers, we can make smart decisions for what people do. Also, developers need to kind of understand what third-party SDKs are gathering, especially when you're creating your privacy policy and things like that, because it's a developer's responsibility to make sure their users are informed and aware of the type of data that their application collects. And if there's any message we have for developers, it's, hey, pay attention to what you're doing and be responsible with what you're doing. And I think I do want to put my hat off to how some SDK providers have dealt with the situation. They make sure developers understand the ramifications of what they're doing. AdMob, for example, this is an excerpt from their SDK. They default location to off in their iPhone SDK, and they ask developers to carefully consider the privacy issue. And I think that's the exact right way to do this. If we're going to get applications to serve targeted geo-targeted ads, hey, make developers aware of it, and make sure they're telling their users about it.
Right.
Makes sense.
And one of the lessons here is just we need to see more developers and SDK developers act like AdMob. So AdMob is taking a really good stance in how they're doing this. The question is the million other tiny SDKs that are out there that really haven't thought about this at all that could be exposing users. That's what we need to be aware of. And we really, really encourage developers to take, as much as they do security, users' privacy seriously.
So the lesson we learned today is that developers don't always know what's inside of their apps. And we hope to encourage developers to really pay attention to what they do put inside of their apps. Third story, I Spy. So we found a huge proportion of applications having third-party code, and we found that users and developers don't always know what's going on. What about other sorts of reasons why somebody might want to access sensitive data? Yeah. Are there apps that could be spying on me? And so we actually dialed up our analysis a little bit and said, okay, what sort of apps are accessing all sorts of really gnarly data? Your IMEI, your IMSI, these are GSM identifiers that can be used for fun things. I hope you guys are staying for DEF CON. We'll see the cell phone sniffing talk. That'll be a good one. Yeah. Browser history, contacts, location, and there's a gamut of other things that you can access and people have been talking about. So the first thing we found was an application by a developer called RxS, and it claimed itself to be a system utility. There were multiple apps in the market, and they all had fairly innocuous names, and a lot of them calling themselves system utilities. Android 15X, Android 16X, Android 20X. Sounds like a home exercise plan, I know. And we say that inside the app, all these applications, they're shuttling a lot of data to mobilespylogs.com/web API. I don't know about you guys. When I see anything connecting to mobilespylogs.com, I get a little nervous. So let's pull out our Icelandic disassembler and look what we see. Ooh, that's interesting. Get SMS details, contact details, URL details, and call contents. Yikes. So what happens when we actually go look at what this site is? Oh boy, it's Mobile Spy. It's our good friend. It's a very popular mobile spy tool. And
who are not our friends.
Depends on whose side of the spying you are So actually, what they're doing is they're instructing their users to basically go to the Android market and download these kind of masked applications.